was the first section, finding an area to the left, right, and between. So we've been doing that. Second section was when we first started having to calculate like z-scores and things. So if I look at this one, it said, suppose time on an iPhone is normally distributed with a mean of 7 hours, minus 7, and a standard deviation of 0.8 hours. What is the probability of spending between 6.5 and 8 hours? So am I talking about like a sample proportion or a sample mean here? No, I don't have a smaller group that I've pulled apart and are looking at something. It's just out of everyone. So this is just finding the probability that x is between 6.5 and 8. So what do we have to do? Z-scores for both. So z is r value minus the mean divided by standard deviation. Okay, so if we calculate those, so I'm finding the probability that z is between a negative 0.63 and a positive 1.25. Then how do you find the probability being between two things? Subtract. You have to look up the bigger one first because we know our answer has to be positive. So if we look up 1.25, we get 8944. If we look up negative 0.63, 0.2643. We get 630. Is that one okay? Next question. The charge life of a battery has a mean 90 minutes and standard deviation of 35 minutes. Part A. What sample size is needed to assume this data is normal? So all in here, I'm talking about the mean. That's all we have. So if we're talking about this mean, what sample size do we have to have? Or if it's not bigger than 30, I have to tell you the original data was normal. So it's one of the two. Okay, find the probability that a sample of 100 has a sample mean less than 80 minutes. So when I see sample mean, that tells me I'm talking about the x bars. You have to check your criteria, which we already said it had to be greater than 30, so 100 is bigger than 30, so we're good there. The mean for the sample means is the same as what? The population mean, which was 90. How do we get the standard deviation for a sample mean? And we get so we're finding the probability that the sample mean, so x bar is less than 80. So we have to get our z, r value minus mean divided by standard deviation. We find the probability that z is less than negative 2.86. Less than is what our table gives us, so we look up negative 2.86 and we get that okay? One last review problem, and then you can finish any problems that you need to from your homework. According to a study, 29% of adults don't own a credit card. Suppose we have a sample of 50 adults. Describe the sampling distribution of p hat. When I say describe it, I'm looking for the criteria, the mean, and the standard deviation. For p hat, we have two criteria. What are they?
It has to be less than 5% of population.
Okay, would 50 be less than 5% of the adult population? Second criteria is n times p. What is my p?
0.2.
Times 1 minus p has to be
Greater or equal to.
and we get 10.295. So that one's good. So we met our criteria. The mean is the same as what? P. So that'd be 0.29. How do we get the standard deviation? So that would be 0.29, 1 minus 0.29, divided by 50. And there's 0.0642. I'm talking about p hats. So if I want probably more than 40 have a credit card. Did I give you the p hat? Okay, how do we find it? X divided by n. So 40 out of 50 is 0.8. So we're finding the probability that the p hat more than is greater than 0.8. So we need our z. Z is our value minus the mean divided by the standard deviation. This was not a very good example. Can I change it? Because this probability is not one we can even look up. This is what happens when I just make up problems on the fly and hope for the best. Let's change it to more than 25. So that'll change my p hat. X over n would become, so 25. All right. And we're still getting a pretty crazy value, aren't we? It's because our sample is fairly small. You notice when we did this, it was very, very close to 10, so it almost wasn't big enough to do it. So I really should have made my original sample bigger. But, all right. How do we do greater than? So if we look up 3.27. And we get